Okay, we're going to take a look at chapters 63 and 66, which have to do with simplifying expressions that have square roots in them. So simplifying square roots. We talked a little bit about this in class, but I wanted to make sure that you had all the information you needed for your homework this week. So in class I showed you the square root of 50. Okay, this is not yet in the simplified form because if you can find a perfect square in this number right here, then we need to factor that out, and then we can simplify it from there. And we talked about in class how the perfect squares are 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. Do you see the pattern? 4 times 4 is 16. So these numbers right here are all perfect squares. They have square roots are a whole number. So if we continue to be 25, 36, 49, and so on. So if we take a look at this number 50, we want to see if any of the factors of 50 are also a perfect square. So the square root of 50 can also be written as the square root of 25 times 2. And then we can write that as square root of 25 times the square root of 2. All three of these things mean the same thing. Square root of 50 is the square root of 25 times 2, all underneath the sign, or the square root of 25 times the square root of 2. When they are put together like that, it's as if they are being multiplied, but you don't have to use the parentheses. From here we can see that the square root of 25 is just 5, and then 5 will be multiplied by the square root of 2 because we cannot simplify that any further. So if they asked you to simplify the square root of 50, your answer would be 5 times the square root of 2. So we're going to take a look at another one. If we have the square root of 200, we can take a look at that number and see that that could also be written as the square root of 100, which is a perfect square, times 2, which can be written as the square root of 100 times the square root of 2, which can be simplified finally. The square root of 100 is 10 times the square root of 2, which cannot be simplified any farther. So the square root of 200 becomes 10 times the square root of 2. So we can also then look at something in chapter 66 where we have square roots of even larger numbers. We talked about this in class today. So if we take a look at the square root of 500,000, well, first of all, we need to find a perfect square within this number. We can rewrite the square root of 500,000 as the square root of 50 times the square root of 10,000. And from there, we know that the square root of 10,000 is 100 because 100 times 100 equals 10,000. So now we have 100 times the square root of 50. But if we remember what we just looked at, the square root of 50 can be simplified even farther, if you remember. So we need to simplify this one even farther. So it becomes 100 times the square root of 25 times the square root of 2, because the square root of 25 times the square root of 2 is the same as the square root of 50. And then we have 100 times the square root of 25, which is 5, times 2. 100 times 5 times the square root of 2, which is equal to 500 times the square root of 2. So that is the answer to the square root of 500,000 can be simplified to 500 times the square root of 2. So you just need to look for perfect squares underneath the square root sign. So the other part of chapter 66 is simplifying expressions. And we can take a look at the square root of 18 plus the square root of 8. Our first step is to look at these and simplify them. The square root of 8 we have to think, does it have a perfect square in it? It does. We can rewrite it as the square root of 9, which is a perfect square, times the square root of 2. Now we're going to take a look at 8. Does it have a perfect square in it? It does. 4 is its perfect square. So we can rewrite that as the square root of 4 times the square root of 2. Now we just simplify. we have 9. The square root of 9 is 3 times the square root of 2, plus the square root of 4 is 2 times the square root of 2. Now, at this point, we can see that we have like terms. Both of these have the square root of 2 in them. So, like I told you in class, that's kind of like saying these are 3 apples plus 2 apples. So 3 apples plus 2 apples would be 5 apples. But of course, we're not adding apples. We're adding square roots of 2. So the answer to the square root of 18 plus the square root of 8, the answer to that is 5 times the square root of 2. So we are going to do one more, just to make sure that you are all set for your homework. We're going to do 8 times the square root of 27 minus 3 times the square root of 75. Again, we're looking at under here the square root of 27, and we're looking for a perfect square. So we have 8 times the square root of 9, which is a perfect square, times the square root of 3. We're going to take away 3, and 75 can be written as the square root of 25 times the square root of 3. The square root of 25 is a perfect square, so that's why we chose that factor to do. So now we have 8 times the square root of 9 is 3, so 8 times 3 is 24. We have 24 times the square root of 3 minus 3 times the square root of 25, which is 5. So 3 times 5 is 15. 15 times the square root of 3. So again, if we look at these and consider these like apples like we talked about in class, we have 24 apples minus 15 apples, which would give us 9 apples. But like I said, that's 9 the square root of 3. So 8 times the square root of 27 minus 3 times the square root of 75 equals 9 times the square root of 3.